Nora and Zeki are on a mission to protect their village from an alien. Few of the villagers are imprisoned by the alien. They have been assigned the task of freeing them. But it's not that easy. They cannot just enter and free the villagers, as it's heavily guarded by a protective layer. If anyone tries to pass this layer, then he would disappear forever. After thorough research and observations, Nora and Zeki finally have a breakthrough. They find a code to disable this layer. They find out that for some time in the evening, the alien takes a nap. This is when they can enter the code and disable the layer. However, the problem is that once the code is entered, the protective layer is disabled for only 45 seconds. And it can be disabled only once. So in 45 seconds, they have to enter the den of the alien and free the villagers and come out.
Hey, this is Ganesh here from Don't Memorize. Before we get to the solution of this riddle, don't forget to subscribe to this channel and hit the bell icon so that you never miss a video from us. Okay, back to where we left off.
Zeki decides that he will be the one who will free the villagers and Nora would be the one who would keep track of time. They just have to measure 45 seconds and accordingly get the villagers out. Sounds easy, isn't it? Well, it would have been easy if they had a watch on. You see, they've forgotten to wear their watches. So now this task seems like mission impossible, isn't it? But Nora doesn't give up so soon. She checks in her bags for some equipment to measure the time. And she finds just what the doctor ordered: 2 ropes and a lighter. She knows that both the ropes take exactly 60 seconds to burn from end to end. But then the problem is that the ropes do not burn at a constant rate. So what do you think? Will they be able to free the villagers on time? Why don't you pause the video and try solving it? To know whether they made it, keep watching the video. Nora did measure out 45 seconds, and within this time, Zeki also freed the villagers, thus saving humanity. But how? Let's have a look. Nora has to be quick, as she does not have time. She has 2 ropes, which would help her in measuring out 60 seconds. But she can neither cut one rope into 2 halves, assuming that it will measure 30 seconds, nor can cut the second rope into 4 halves, assuming it will measure 15 seconds. That's because the ropes do not burn at a constant rate. No luck here. So how would she go about it? Nora takes a look at the rope once again. She does know this fact that both the ropes take exactly 60 seconds to burn from end to end. And that's when it hits her that this is the key to this puzzle. Confused? Don't be. Let's understand this well with the help of a relatable example. Okay, now imagine a road which is 120 kilometers long. For our convenience, we shall mark these points as A and B. Let's assume that the road isn't uniform, thus the speed of the car will also not be uniform. Yet the car always manages to cover this distance in 60 minutes. That is, if the car starts from point A, it would take exactly 10 minutes to cover the first 30 kilometers. It would take another 30 minutes to cover the next 30 kilometers. And further, the car would travel the remaining 30 and 30 kilometers in 5 and 15 minutes respectively. That sums up to 120 kilometers in 60 minutes. Now let me ask you a question. What's the total distance traveled by the car in 30 minutes? Let's try solving it. In 10 minutes, it travels 30 kilometers. So let's just write 30 here. Okay, for the next part, we need to find the distance traveled in the next 20 minutes. Tricky, right? Here we know that in 30 minutes, the car travels 30 kilometers, which means it travels at the speed of 1 kilometer per minute. So now, can you tell me how much distance will be traveled in 20 minutes? That's correct, 20 kilometers. We write this 20 here. Here it is. In 30 minutes, car covers 50 kilometers. Thus, we can establish here that in the next 30 minutes, the car will cover the remaining 70 kilometers. Okay, now consider this scenario. what if the car starts from point B instead of point A? Then it will cover 30, 30, 30 and 30 kilometers in 15, 5, 30 and 10 minutes respectively. Now let me ask you the same question which I'd asked you before. What is the total distance travelled by the car in 30 minutes? In 15 minutes, it travels 30 kilometers. We write 30 here. In 5 minutes, it travels another 30 kilometers. We write 30 here. Okay, now comes the interesting part. We know that it takes 30 minutes to cover these 30 kilometers. So by applying the same logic, we can say that in 10 minutes, it travels 10 kilometers. Here you go. In 30 minutes, the car travels 70 kilometers. Thus, we can establish here that in the next 30 minutes, the car will cover the remaining 50 kilometers. So if there are two cars at points A and B moving towards each other, and they start at the same time, then they would meet each other exactly after 30 minutes. That is half the time taken to travel the entire distance. Bingo! Now you may say, what if we change the kilometers? Will this still work? Yes, it will. Now imagine a road stretching up to 100 kilometers. And this is the distance travelled in 10, 5, 10 and 5 minutes respectively. That is 30 minutes in all. If you observe, here as well, we shall find that if two cars move towards each other, then their time of intersection would be half the time taken to travel the full distance, that is 15 minutes. Now Nora gets a hold of a strategy to calculate 30 seconds. That is, Nora would ignite both the ends of the rope. We know from what we've seen earlier that if the rope is lit on both ends simultaneously, then it would burn out precisely in 30 seconds, which is half of 60 seconds. Here Nora is able to measure 30 seconds. But then what about the remaining 15 seconds? It will definitely come from the second rope. How would she go about it? Well, she applies the same logic. Confused? Let's look at the strategy and know how Nora saved the day. Okay, we know that Nora will ignite both the ends of the first rope simultaneously. But here's the catch. At the exact same time, she will ignite one end of the second rope too. Now when the first rope completely burns off, Nora knows that 30 seconds have passed. So now Nora has measured 30 seconds. This means Nora is left with 30 seconds on the second rope. How much more does she want to measure? That's right, 15 seconds. Can you tell me how can she measure 15 seconds from these remaining 30 seconds? Think about it. Yes, exactly. If at this exact moment Nora ignites this end of the second rope, then she would be sure that this rope will burn off in 15 seconds, that is half of 30 seconds. And that's how she can measure 45 seconds in all by measuring 30 seconds from the first rope and then 15 from the second. Eureka! And within this time, Zeki can free the villagers. They implement the strategy and successfully complete the mission. Nora's logical skills did prove as the savior of humanity. Interesting, isn't it? Now before signing off, here's a question for you. What if instead of 45 seconds, Nora had to measure 50 seconds? How would she devise a strategy for the same? Share your strategies in the comments section. And for more interesting riddles, do subscribe to our channel. Good luck with solving!